Good morning, good afternoon, good evening, depending where you're joining us from. Um, Today we are going to solve CTF number 9. It's an actual really interesting one. It's part of Wizer's secure coding challenges that come with the Wizer platform. We have a public version, which is what you're seeing. So this is the community edition, and we are going to show you the solution for the CTF. Yeah. With that said, you know what? I'll just hand it off to you, Itzik, and
Yep.
let's start with explaining what the challenge was, and then how to solve it.
Thank you, Gabby. So on this one, this is a card creator app, okay? And we are, or a part of it, and we are trying. So the goal for us is to read the content of the OS file past WT to show that we can read files that are outside of what we're expected to be able to do. And this card creator, so let's review the code and see how it's even built. So this card creator has one method. It's actually Next.js. It's one API endpoint that what it does, it actually pulls the role, the first name, the last name as arguments from the input, and then it plugs them into an XML. Okay, old but still exists out there. So it's an XML, and then it plugs them into entity arguments. What is that? That is a way for XML to actually define global arguments and then replace them within the XML itself. So you can have multiple occurrences of first name, multiple occurrences of role, and you can build all sorts of structures based on these arguments, which comes as an input. So as you can see here, the card that is created just creates a full ref, which is first name, last name, role, and then the first name and last name. Very simple, not necessarily real life, but could have been real life if we invested a lot in creating the card. So then what it does, it parses the XML here, and it replaces the entities, which is really important in this case, and creates the card. Okay, it creates the cards and it sends it back as a string to the requester, to the person who invokes the invoker of the API. That's it. That's basically the entire code.
Okay, so
So
just to recap, the challenges is to use this piece of code to be able to access a system file, in this case, the password file. So this is an example of how somebody can use a website or an API to pull out the passwords from a specific server, the system passwords, like the
it's not, yeah,
administrator.
it's not password, it's pass WD, it's a different file. It doesn't include actually password, but it is definitely sensitive and not accessible generally to anyone. Shouldn't be, because it
Okay.
includes sensitive information.
But basically, a system file
Exactly.
on the OS, we don't want anybody from the web
Read.
being
Yeah.
able to do some magic and through our web app gain access to the system.
Absolutely not.
Okay.
Absolutely not. Okay.
So
So
let's
how
see
do we
how you
solve
do
it?
this. Yep.
How do we solve it, right? So in this case, okay, we see that the developer actually thought about an option of injecting entities. So let me step back and explain. In XML, there is entities of all sorts of types. This one is a simple entity, just a value. There could be a system entity. A system entity is actually goes to outside of the XML and brings some values. It could brings a file. It could bring a file. Could actually make a request and bring the content. So in this case, to prevent entities from being generated by the end user, the developer created a simple sanitize input um, method, which what it does, it goes and removes the characters smaller than exclamation point, which apparently, or at least what the developer planned, is that it won't be able, the user won't be able to insert any new entity. That was the intention. Okay. However, this is not good enough, and people are still able to inject entities, and definitely a system entity. And I'll show you how it's done. Fairly, fairly easy. Okay. So I'm going to copy the solution, and then we're going to talk about exactly how it's done. So, okay. So here's the solution. That actually solves it. But why does it solve it? Okay. So let's take that first line, which is what we're plugging in. I'm actually inserting the value into first name. So I'm going to take that first line. Okay, I'm just going to put it here just for a second for us to kind of like explore. So what am I saying here? I'm taking this, okay, and plugging it into the first name, right? That's what I'm doing. So let's do that, okay? So what am I doing here? First of all, I'm escaping it. So I'm putting first name A, and then I don't terminate the string yet. I just escape the closing quotes so that I can say, okay, now first name ends. Now I'm closing the entity and I'm opening a new entity. But here, look at this. I'm doing smaller, smaller, exclamation point, less exclamation point. Why am I doing that? An old trick for hackers. The replace all will do this, right? It will actually replace all the occurrences of smaller than exclamation point, and that's exactly what's going to happen. Okay.
This
So
is
now
happening because show the line of code that does that.
that is the line of code here.
Cool.
Okay. And so then I have a new entity. And in under last name, which is one that I'm using in the XML, which is good, so I can get the output, I'm plugging in a system entity, which goes and grabs the file. Oops. Sorry about that. I actually refreshed it unintentionally. Let me do it again. So I'm actually going to take that again, take that line. Okay, and replace it again. So we can do it. Okay, and then this is the replace results. And then actually I'm creating a system entity that goes and fetches past WD, and then it plots here. It actually prints it under last name. So the last name is going to actually include the content of past WD. If you want it happening, if you want to see it, you can use you can use Postman, run it, and you'll see the content of past WD in your output.
Great. So this is basically using the XML to fetch the password or the PW, the pass WD file, and because we're using the last name, which is already defined, we can basically reflect it back to the user. So now the attacker has this says this system file. It's reflected back to the attacker.
Exactly.
Okay, cool. So talk to us a little bit about what are the key takeaways and what can we do. And what I really like about this example is that the developer was thinking about this risk, right? So they actually included a solution which dealt with a symptom, but not with the core root problem. So I want you to talk a little bit about that as well, because it's something that we see a lot when developers don't have the mindset of an attacker and they're trying to solve something in a way without understanding the root cause of this problem. So
exactly, and it happens
I'll
a
give
lot.
it back to you.
You're right. So the first takeaway is exactly about that, is you have to choose a proven sanitization approach. So instead of saying, oh, that could happen, then let's do this, there are libraries out there, there are methods, there are articles. The internet is full of how to prevent XXE, okay? So choose a proven sanitization method. Create a whitelist instead of an allow list, instead of a blacklist or a deny list, right? You can say, here's what I allow versus here's what I deny. Then this wouldn't have happened, right? So if you had some stronger and more comprehensive sanitization process, this wouldn't have happened, okay? So that's the first and I think more important takeaway. However, there's also a takeaway about the XML libraries and the XXE. So XXE has been around for, again, almost like SQL injection, 20 years, even more. So, but it's old and people still use it. So yes, people are not using XML anymore or a lot, but there are still a ton of legacy systems that are using XML for multiple reasons, and the vulnerability exists still in the wild, even in very sophisticated systems, as a backend or a legacy portion of the app and so forth. So you have to acknowledge that. So if you're looking at making sure that your app is really secure, check your library and browse the risks, and you will find out what XXE vulnerabilities exist. And you can do one of the following. Some libraries allow you to block system variables or system entities. That will solve it, because then variables and values are simple values, and you won't be able to mess around with them. Some don't do that. Like this library that I'm using here, they don't have a configuration. But what I could have done in this case, it's a little stupid what is done here. I mean, it's legacy and people used to do that. But the first name here is plugged into a variable, which then in turn is being plugged into the actual card. But we could have taken this directly and plug it in here. That would have worked the same way. And we don't need to go through the XML vulnerable capability that is not required and is even actually is maybe heavier and taking more process cycles. So it's not necessary here. So evaluate whether you need those capabilities and block them. Don't use them. Make sense, Gabby, so far?
Yes, absolutely.
Okay. And so the last one is, just remember that XXE, actually, it's not the last one. I already talked about it, but XXE is really out there. And recently, we're working with a lot of pen testers and with a lot of hackers. And they tell us we are surprised to see all those old vulnerabilities still exist in the wild. XXE included. Recently, again, 2 weeks ago, 2 or 3 weeks ago, a pen test found it in an app that is relatively modern.
So all of these key takeaways are in the write-up, correct? So what
Absolutely.
we're looking right now, can you go back for a second?
Yep.
So just for the people that are new to the CTF platform, anything that is purple is basically archived, not archived, is retired.
Mm-hmm.
So these are retired. We'll show you in a second what the active ones look like. So the retired ones are those that have write-ups. So everything we said today is also in the write-up. Can you click on the write-up?
Yeah, it's here, but yeah, let me click it to demonstrate. But you click it, opens, and it shows you, and what it includes, as always, is the goal, which is very basic. Then description of the code is what is it trying to do? Okay, as we talked about it, and then the code itself. What's wrong with that approach? The kind of like high level wrong thing. It's not the takeaway yet, but it's what's wrong with this. And then a successful attack. It's how does it look? You can see here how would a successful attack look like, because the pass WD values are right now here. So you can see that it's not a natural thing to see under the value. And so you can see here that it's specified what you can do to bypass it and so forth, but you still can't copy and paste the solution and plug it in. The so what tells us, why is that important? Why do we care about it? Okay, so there's a vulnerability. What's the big deal? I mean, that's a big deal, because if you can include sensitive files, it can be keys, it can be all sorts of things that can help you as a hacker or as an attacker to achieve multiple goals. And then main takeaways are down here, as we talked about before. It includes what we just discussed. You need to Google and understand and find a proven sanitization strategy, use it, and so forth.
Great. So guys, this is in the OWASP top 10. So definitely this is in the wild. The OWASP top 10, just like it sounds, is the top 10 vulnerabilities that are out there and that people need to pay attention to. So even though you may think, oh, XML, this is still very much out there. It's a great write-up. And I think this is a great way to educate your dev team and have them, because the solution is not the payload, is not listed here. So you read, you understand the solution, but you still need to come up with the payload yourself. And this is still active. So it's retired, but you can still try it out. So if you go back, the payload can be pasted here, and you can try it out. You won't get into the leaderboard, but you can see if your solution works. with
right?
regards to new CTFs, every week, every 2 weeks, we have a new CTF and we retire an old one. So one comes in, one goes out. So if you go to the latest challenges, we're talking 30 to 35. All of these are active. They are this orange red. They're all active. There are different peppers for the difficulty for each one of them. So if you want to be in the leaderboard, you can go ahead and try them out. And if you wait a little bit, we'll have a write up for each one of them once they're retired. And you can also join our Discord. There is an icon here, and you can collaborate or chat with other people and try to figure out how to solve it. This is such a great tool to learn secure coding. It's a red team activity. Developers love this. I very much encourage, and it's free. This is a public version. This is free. So I really encourage any company to send their developers here and try this out. So with
That's
that said,
yep.
Itzik, thank you very much. We'll meet again here in a week. We're gonna go over challenge 10, I guess,
Number 10. Yep.
number 10. And until then, um, have a great weekend, and thank you very much for joining us.
Thank you all.
Bye bye.